Everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own after a lot of struggling, so I'm really happy about this. Again, my own solution isn't the most efficient, but it does work, so let's go over it. Basically, you have a circular array, and at each index you want to basically say nums of 0 is 1, find the closest element or the closest index value to 0 that is also a 1, and you want to do this in a circular manner. So notice that this is actually shorter than this. So this would be 3 for index 5, 0, 1, 2, 3, 4, 5, or I mean this 3 and this 3. The distance around is closer than this, so it gets a little bit tricky. But what we want to do is first create a default dictionary of type sorted list so we can use binary search. And so we're going to create a set, and we're going to get the total length, which we're going to use later. And then we're going to iterate over our queries. And we're going to say the value is nums of q because index 0 is the one we want here. And then now what we want to do is say current. We want to keep track of all those values because we want to put, so 1, we want to see all the indexes where 1 is at, and we're going to iterate over nums again to do this. So for I, n in enumerate nums, d of n dot add I for the sorted list syntax. And it's easier to just see this. So now you can see index or value 1 appears at index 0, 2, and 4, and vice versa. So now we have what we need to run our binary search. So now, so for the current, we want to find the closest in this list. So let's print, so which keys value list do we need? That's going to be called options is d of nums of q. So let's print q and options. Cool. So now we have this. So the index is value in here, and that index is value list in the dictionary. It gets quite confusing. Cool. So now we have this. Now we want to find the closest value that's not equal to it, and we want to do the circular thing. So let's call this cur, or now is float of infinity. At the end, if now is equal to this, then we know we didn't find an answer. Otherwise, we did. So now equals to this, or answer that was going to return at the end. Okay, so now if the size is small, then we can just loop through options, right? Because that's the index that we need as long as it's not equal to q, right? So this is q, we see 0, we can't have that. We only can compare the other ones. So in this case, now is minimum of now, and this is a bit confusing because it's absolute value. Okay, let's take care of the first criteria first. It's absolute value of q minus a, right? And so you can see that that doesn't work for the circular kind. So the circular one needs, as I said, 3 this way is smaller than this way. So absolute value of total minus q. So 7 minus 5 plus a. So that's going to be better. But then this, we have to take care of that. So let's print total and q and a just so you can see. Okay. So also absolute value of total minus q. No. Plus a minus q. Okay. Total minus a. And this will get you most of the way there, but now you have a minus q as well. and total minus a plus q. So just think about this way and also this way. And then now you have, okay, now it gets even more confusing because we're going to use a binary search instead of having to loop through this whole list to get the value. So it's going to be bisect left inside of options and Q to find the closest index. Bisect right instead of options. Let's just kind of cast a large net. So now for J in range, BL -1 to B right +1, because we know that's the range it's going to fall inside of. So if J is bigger than or equal to 0 and J is less than length of options. Okay, now we have if options of J is not equal to Q, then we can do this again. So this is actually an index now, right? So, oh, okay. A equals options of J. And there you go, passes all test cases. This is not the most efficient solution, but took me quite a while to come up with this on my own, but I did, so pretty happy about that. So other than that, I don't know if I can come up with this again in like a week without struggling really hard, but I did it. So thank you for watching and stay tuned for more.